Integrating dx over root of 3 minus 2x minus x squared. So to do this one first, I can't really see what kind of a function it is. So the best way to do this, I'm going to complete the square of the inside the function of the square root. So I have minus x squared minus 2x plus 3. I'll need to complete the square of this one, then I see what result I'm going to have. If I can easily relate it to some other functions, then it will be okay. So completing the square here first, I'm going to make the coefficient of x squared to be equal to 1, and to do that I'm going to factor a negative 1 outside. So negative 1 is out, meaning that for x squared it's going to be positive. For negative 2x is going to be positive as well, 2x. For positive 3 it's going to be negative 3. Since we have our x squared with a coefficient of 1, I'm going to multiply 2x by half. So multiplying 2x by half, I get 1. Then I'm going to add the result and square it, then subtract the result and square it. So I'm going to have negative 1 x plus 1, and we square it, minus 1 squared minus 3. So you always add it to x, then square, then subtract the square of it, minus 3. With this, you can say, or negative 1, which is outside, then x plus 1 squared. Simplifying here, we get negative 4 as our answer. Distributing the negative back, we are going to have negative of x plus 1 squared plus 4. Then I'll take this back into my integral, meaning I'm going to have the integral of from negative 1 to 0 dx over the square root of 4 minus x plus 1 squared. With this, I can easily relate to some function that I know well, to say the derivative of tan inverse of x is simply, with respect to x, is simply equal to 1 over, alright, not tan inverse, but I think sine inverse. Yeah, this one is for sine. So we know that the derivative with respect to x of sine inverse of x is going to be equal to 1 over square root of 1 minus x squared, which is kind of similar to this one. So how do we manipulate this one to look exactly like this one? The first thing is I'm going to factor out this 4 so that it can be a 1 here. So doing that, I'm going to have the integral from negative 1 to 0. When you factor out a 4, it's going to be dx over root of 4 multiplied by 1 minus, since there was a 4 here, it's going to be a 1. Then here we have no 4, so it's going to be over 4, x plus 1 squared over 4. But it's not exactly the way we want it. What we want is to have everything squared. So to do that, we're going to say the integral from 1 to 0, the square root of 4, it's a 2, then dx, then we have the square root of 1 minus, so to make this as a whole with a square outside, it's going to be x plus 1 over 2, then we square everything. With this, we can say it's now similar. So the integral of this one is simply 1 over 2 sine of x plus 1 over 2 plus c. Then after writing this, since we've noticed, say this is the sine inverse of a function, so the next part that we're supposed to do here is to differentiate this angle. So after differentiating this angle, we get 1 over 2. In normal sense, when we are differentiating the function, we are going to say the differentiation of the angle multiplied by the whole function. But since we are integrating, we are not going to multiply by the whole function, but we are going to divide. So when you differentiate, the inside function is giving you 1 over 2. Then we are going to say everything over 1 over 2. Simplifying this part, it's going to give us sine inverse of x plus 1 over 2 plus c. So since we have limits, we can plug them in. So we have sine inverse of the upper limit is 0, so it's 0 plus 1 over 2 minus the lower limit, sine inverse of the lower limit is -1, so -1 plus 1 over 2. When you're using degree mode, you are going to have sine inverse of half minus sine inverse of 0. So in degree mode, sine inverse of half is 30 degrees minus sine inverse of 0, it's 0, meaning that in degree mode we have 30 degrees. You might want to convert this into radians. That's your job.